Hello, Calculus. We are going to look at a topic called logarithmic differentiation, and it's going to be viewed after Thursday's class. So you have Friday, Thursday. Well, I'm getting it up late Thursday, either late Thursday, Friday, Saturday, or Sunday. All right. We just learned about logs. So the important one is y equals ln of u. Y prime is 1 over u du dx. Alright, so we're going to use that one to actually differentiate an expression. And the reason we use it is that it takes, because of log rules, we can take an expression and simplify it. So see what you think. Here's an expression that we could differentiate. We could do the quotient rule and use the chain rule in the middle of it and then try to simplify it. Alright, watch this way and see if you like it. To use logarithmic differentiation, you see a situation where you could use log rules to simplify it. So in order to use log rules, you have to have some logs. So there is an operation in math which is legit, and you can take the ln or any log as long as it's the same log on both sides. But since I'm hoping to use this principle, I'm taking the ln. So I'm taking the ln of this side and the ln of this side. I'll write this to the 1/2 at this point. Alright, so now before I go further, I'm going to use log rules to undo this. So when we have a quotient, it's like taking the logarithms and changing them to a difference. Alright. And now I can continue. The 2 can run down in front this time. When the whole argument has a power here, it can run down in front. And this one can as well. Alright, now I'm ready to take the derivative implicitly across. So when I get to ln of y is an expression with x in it. I'm going to use this principle and get 1 over y dy dx. Alright, that's what I'm really trying to find. I'm trying to find y prime or dy dx. Same thing. Alright, so this is what I'm going to be solving for. I continue implicitly differentiating. So the derivative of this I've learned recently. The 2 remains, and we have 1 over u, and du dx is just derivative of that, and it's 1, so I don't have to write anything. Over here I get 1/2, and in the denominator along with it I get 1 over my u expression. This time I do have a du dx. The derivative of this expression is 2x. Alright, in this term the 2's cancel, so I'll take care of that right away. And I can move the y to the other side by multiplying both sides by y. So all that is multiplied by y now. So that's the answer, but it can be simplified. So we love to simplify our answers. And let's see. Let us give this term the same denominator. So these two terms, the same denominator. So I'm going to give it the common denominator, x minus 2, x squared plus 1. And when I do that, this needs the x squared plus 1, and this needs the x minus 2. Alright, so multiplying, oh yeah, and this still times y. Multiply out in the numerator, I'll leave the denominator factored. We get 2x squared plus 2 minus x squared plus 2x. So pulling those together, I get an x squared, a 2x, and a plus 2 over the factored denom. And instead of writing this as y, I'm going to use an expression in x, which I can find up here a little bit. This expression right here. So coming back here, I change y to x minus 2 quantity squared over square root of x squared plus 1. Alright. So this is a same factor, so I'll take that, and now we have an x squared plus 1 to the 1 times an x squared plus 1 to the 1/2. So we can multiply these by adding their exponents. So there's not a whole lot left I can do, is there? I think I'll just leave this factored. 1 plus a half is 3/2. Alright, that's good enough. So I don't want to spend the whole time on the algebra when I was more interested in the calculus. Alright, logarithmic differentiation will entertain us on Monday. So, see you then.